This video goes over how to find sides and angles using the three primary trig ratios. So one thing that you will need to know is this acronym here, SOHCAHTOA. And the first example that we're going to do is solving for a missing side. So we're trying to find x accurate to one decimal place. This is important. Make sure your calculator is in degree mode. It should say a little d or DEG at the top. Okay. So we're going to start with our angle and identifying our opposite, adjacent, and hypotenuse. So directly across the triangle, we have our opposite side. Beside our angle, we have our adjacent side. And of course, across from the right angle, we have our hypotenuse. So we are looking for the trig ratio to use that has our adjacent side and our hypotenuse in it. That ratio is our cosine ratio. So we're going to write our cosine ratio in general and then substitute in what we know. So cosine 22, that's our angle. Our adjacent side is x and our hypotenuse is 7. Multiplying both sides by 7 is going to give us that x is equal to 7 times the cosine of 22. And that we can evaluate on our calculator. 6.5 centimeters. The next example that we're going to do starts off here. So we've got our angle is 57. Directly across from that is our opposite side. Beside our angle is our adjacent, and then across from the 90 degree is our hypotenuse. So we are looking for a trig ratio that uses the opposite side and the adjacent side, which is going to be our tan ratio. So tan theta is our opposite over adjacent. Filling in what we know, tan 57 is our opposite side over our adjacent side. Multiplying again both sides by 2 gives us 2 tan 57, which gives us a side length of 3.1 centimeters. Let's move on to our third example here, putting in our right angle. We're starting with our angle of 61 degrees here. We need to identify our sides. Directly across the triangle, we have our opposite side. Our other shorter side is the adjacent side, and then directly across from the right angle is our hypotenuse. Here we are looking for a trig ratio that uses our opposite side and our hypotenuse. That is going to be our sine ratio. So writing out our sine ratio in general, sine theta is equal to opposite over hypotenuse, and then substituting in what we know. Sine 61 is equal to our opposite side, which is x, over our hypotenuse, which is 17. And then here again, multiplying both sides by 17 gives us 17 sine 61. Putting that into your calculator. Making sure you type all the values correctly should give you 14.9 millimeters. Our last example here of finding the side, we've got our angle 34. Directly across is our opposite side. Our other shorter side is our adjacent. And across from the right angle is our hypotenuse. So we are looking for a trig ratio that uses our opposite side and our adjacent side. That's going to be our tan ratio, the TOA part of our acronym. So we can start by writing tan theta in general, and then substituting in what we know. 34 for the angle, 10 for our opposite side, and x for our adjacent. Okay, here the trick to solving is just to switch the x and the tan 34. This is the same as multiplying both sides by x and then dividing both sides by tan 34. What it comes out to is switching the left side and the denominator. Evaluating that on your calculator gives you a value of 14.8 centimeters. The other part that you should be able to do is to solve for a missing angle. So that's what our examples are going to be down here. In our first example, we're looking for our angle x. So we're going to start off the same way that we did above, identifying our sides. Our opposite side, our adjacent side, and our hypotenuse. Now we're looking for a trig ratio that has our two sides in it. So our opposite and hypotenuse. That is our sine ratio. So again, I'm going to start off the exact same way that I did when I was finding a missing side. When I substitute in the values that I know and don't know, I'm going to have an x for my angle, and I'm going to know what my ratio is on the other side. And I'm just going to make an edit here because our hypotenuse should be the longest side. So let's write this as 10 and 15. Just going to change my values here. So I would have my opposite side is 10 and my hypotenuse is 15. In order to solve for x, I need to take the sine inverse of both sides. Sine inverse of sine just leaves you with the argument, with his x. And then on my right hand side, I've got the sine inverse of 10 divided by 15, which is 42 degrees, rounded to the nearest degree. Let's do another example here. Starting the same way with our angle and identifying our sides, our opposite, our adjacent, and our hypotenuse. So we need a trig ratio that uses our adjacent and our hypotenuse. That would be our cos ratio. So cos theta equals adjacent over hypotenuse. And now we're going to substitute in what we know. So cos x equals 12 over 35, taking the cosine inverse of both sides, and then plugging it into our calculator, is going to give us an angle of 70 degrees. Our final example here starts with x, and we're going to identify our sides, opposite, adjacent, and hypotenuse. You don't need to write this down every time, but it is helpful when you are first starting out. Here we're looking for a ratio that uses our opposite side, and our adjacent side, which I've already started to write down here, is tan. And now I'm going to substitute what I know and what I don't know. X for my angle, 8 for my opposite side, and then 17 for my adjacent side. Solving for x by taking the tan inverse of both sides is going to give me a value of 25 degrees, rounded to the nearest degree. Those are examples of two skills that you should be able to do using right angle